what's the longest stick that can be placed inside a box that has the inner dimensions of 2 inches by 5 inches by 3 inches? Okay, so in order to imagine this, you want to draw like a three-dimensional box. Okay, so you're looking at this box, and again, if I put the dashed lines to kind of show in behind. And if I label this, we have 2 by 5 by 3. All right, now in order to figure out what's the longest uh, item that can be placed in here, the furthest distance from point to point in this solid is going to be one bottom corner to where? The opposite. So the opposite corner on the other side, would it be the top or the bottom? So this top one's going to be the longest piece is going to fit from the bottom of one corner to the top of the opposite corner. Does everybody see that in this image? All right, so this is the length that we're looking for. Now, in order for us to find this, we don't have enough information that's provided here, right? We have this vertical line that comes straight down. We have these two sides, these lines on the side here, but those aren't attached to this vertical line, or this line across the box. And so what we need to do in order to solve this is add in one more reference line, and that reference line is going to be the diagonal across the bottom of the box. And the reason for that is, what kind of a shape is formed in green here? A right triangle. Okay, so we look at this, and then when we look at the upper part, that diagonal across the bottom also happens to be a leg of a right triangle in blue that allows us to find that diagonal across. Okay, so if we look at the math for this, we have Pythagorean theorem. So a squared plus b squared equals c squared. So we know that 2 squared plus 5 squared is equal to, and I'll call this c squared. C is the diagonal across the bottom. And so if we add these together, 4 plus 25 equals c squared, or 29 equals c squared. Okay, now, do we need to know what c is? I mean, it's easy here, right? C is going to be the square root of 29. But in this particular problem, we don't even need to go through that step. There's no reason to do that step or to simplify it or anything, because when we go through our next Pythagorean theorem, the square of our leg is 3 squared plus c squared. Well, what is c squared? We could plug it in directly. C squared is 29. So you could say root 29 squared. It's redundant. If you can plan ahead and skip that step, it just saves you a little bit of time. And then that's equal to, and we'll call the diagonal, the length of the stick itself is d. The diagonal of that is d squared. So again, that was Pythagorean theorem. The sum of the squares of the legs is equal to the square of that hypotenuse. And now we can solve for that. Here, 9 plus 29 is equal to d squared. 38 equals d squared. And for this one, you do want to simplify it all the way down to d. And depending on what they ask you, the exact answer. Are there any perfect square factors you can remove from 38? No. So you just leave it in that form for right here.